Stick your hand in the oven to grab a lasagna and you're fine, but when you touch the dish, you burn your hand instantly. What gives? I mean, the oven is the same temperature as the quiche, right? The key is in the stuff. Let's talk about it. So most people think that if something is hot, it'll burn you, and that's generally a good rule of thumb, at least until it isn't. See, temperature is a measure of the average energy of the particles that make something up. The more energy they have, the higher the temperature. But it's not average energy that burns you, it's total energy. Think for a moment about what actually happens when you get burned. The cells in the affected area get too hot and they stop working. I don't know the details, I'm no biologist, but the point is, it takes a certain amount of thermal energy to cause a cell to stop working. And if a burn is serious, it means lots of cells stop working in a short period of time. And that means lots of energy gets transferred to your body in that same short period of time. Now there's two properties of a thing that tell you how much energy it'll transfer to you if you touch it when it's hot. The first is how much total thermal energy the thing you're touching has. The second is how quickly that energy will flow. Let's zoom in and think about what happens when you get burned by the pot pie in the oven. You grab the dish and the molecules at the surface of the dish give some of their energy to your hand. Then some of the other molecules deeper in the dish give their energy to the molecules at the surface, and then the molecules at the surface give more energy to your hand. This basically happens until your hand and the dish are at the same temperature, but you'll be burned far before that happens. Now, if the dish wasn't able to transfer energy from deeper layers to the surface efficiently, then energy would get transferred to your hand more slowly. We quantify the ability to redistribute thermal energy this way with something called thermal conductivity. The higher it is, the faster energy can go from the pumpkin pie dish to your hand. The second factor is how much total energy the casserole dish stores, and we quantify this with something called heat capacity. The bigger the heat capacity, the more energy it takes to change the temperature of the brownies. This matters because energy flow only happens until the temperature of your hand matches the temperature of the turkey dinner. If the heat capacity was too small, it wouldn't matter how fast the energy can be transferred to your hand, there's just not enough energy to burn you. And it's both of these factors that make it safe to stick your hand in the oven, but not safe to touch the baked potatoes. As a gas, air doesn't conduct heat well because the molecules are not stuck together. This is why you may have heard that air is a great thermal insulator. And because air doesn't have a lot of mass, again because it's a gas, it can't hold very much thermal energy, even at high temperatures. As an aside, this is why the very high temperature of the Van Allen radiation belt is not a concern. They're billions of times less dense than even air, so its thermal conductivity and heat capacity are basically zero. So make sure to wear oven mitts when you stick your hand in the oven. That is, unless you don't plan on touching the dish.